Hello students, today we are solving literal equations. So before we can do that, we need to make sure that we know what operations are inverses of each other. Okay, adding the inverse is subtracting and vice versa. Multiplying the inverse is dividing and vice versa. Okay, so these two should go together and these two should go together. And then it's about putting it into practice. So remember, solving two-step equations, I get rid of the constant term first. That is my minus 12. To undo a minus, I have to add, because that is, the inverse of subtracting. Whatever I do to one side, I do to the other. So I have x over 9 equals 8. X right now is being divided by 9. So I'm going to do the inverse of dividing and multiply. My 9's cancel out and I'm left with x alone equals 72. So from here, literal equations are equations that involve many unsolved, cross that one out, variables. Formulas are a perfect example of literal equations. So we have formulas and we have plenty in math, but formulas typically become super duper important in science. So, or in your everyday life. So we've got the formula that goes with miles per hour. So think you're going to be driving a car. Miles per hour would be your distance formula, like a distance formula. So if you've gone 75 miles in an hour, then you've gone 75 miles. But what if you need to talk about a 3-hour drive? That pops up in a formula. So we need to be able to solve for specific variables in the literal equations. For example, in here I'm going to be solving for b. Step 1, when I'm doing literal equations, is I need to know which variable I'm trying to solve. Delta Math's always going to give it to you. Solve for b. So I am trying to get b alone. Okay. After that, I need to move everything away from b. That's what solve means. Solve means I need to get b alone. So I need to move everything around to make sure b gets alone. So I see b has a negative attached to it and a 6a. So I need to move what's furthest away from the b away first. 6a is positive 6. So that means my inverse operation would be subtracting 6a. I'm going to subtract 6a from both sides. They cancel out over here. I don't need to know what a is. I just know it's going to go away because 6a minus 6a is going to be 0 no matter what a is. And I'm left with negative b equals, can I squish the c and the 6a together? The answer is no. A and c are not the same letter, so they are going to stay separate. I do not have to simplify anything. That's the cool thing about literal equations. You're not simplifying at all. You get to just keep tacking things on until you get your letter alone. My last thing is a negative. Okay, this negative is a secret negative 1. Remember, when we don't have a letter there, there's a secret 1. And that secret 1 is being multiplied by the b. So I'm going to divide by negative 1 to everything in my formula. Everything in my equation, excuse me. The negative 1's cancel out, and I'm left with b by itself equals c divided by negative 1. that's just going to flip the sign. So positive c is going to become negative c. Negative 6a is going to become positive 6a. b equals this. And that is what's going to go into Delta Math. Okay, let's practice it a couple more times. So here's some more formulas. This one's a math one. There's your distance, like normal distance. Okay, if I am trying to solve for h, I have a equals 1/2 times b times h. Remember, when there's nothing there, there's a secret multiplying. And I'm trying to get h alone. Okay? So that means everything around h needs to go away. And they're all being multiplied. The way that I undo multiplication is I divide. So 1/2 and b need to be divided on both sides. Oop. So on my right, they're going to cancel out. And I'm going to be left with h all by itself, which is what I wanted. And on the left, no simplifying required. I have a divided by, because I had to divide, 1/2 times b. And that's what I'd put in a Delta Math. Okay. What if I came over here and I said, we need to solve for r? Okay, I've got d equals r. When they're right next to each other, that's multiplying r times t. I'm trying to get everything around the r away. R is being multiplied to the t. So I'm going to divide the t. On my right, t's cancel out. And I'm left with r by itself, which is what I wanted because that's what I was solving for, equals d over t. And d over t is what I'd put into Delta Math. Hopefully we're catching the pattern. And hopefully you're noticing that we don't have to do any calculator work because we don't have any numbers to put in. It's all just letters. Okay, this one's where it gets a little tricky. Let's say I'm being asked to solve for x. I have p equals c times x over 5. Okay, I can do this a couple different ways. The quickest way for my brain is I can do the inverse operations at the same time. So if I'm trying to get c and 5 away from the x, c is being multiplied to the x, so I can divide c. 5 is being divided by the x, so I can multiply 5. What happens is the c and the x switch places and they cross out. And I just go over here and I do the exact same thing. I do 5 over c. 5 is being multiplied, c is being divided. And I would then just put them together. 5 and p on top, because p is p over 1, and c on the bottom. 1c. Okay, if you're like, that didn't work for me, that hurt my brain, let's do it separately. Okay, I've got p equals c times x over 5. Okay, I see that I have a divide by 5. So I need to multiply by 5 on both sides. And that cancels out on my right, and I'm left with 5 times p equals cx. And I'm trying to solve for x. C is being multiplied by the x, so I'm going to divide by c on both sides. Cancels out on my right, and I'm left with 5 times p over c equals x all alone, meaning 5 times p over c is my answer. And notice that's exactly what we got over here too. Just we added an extra step. Okay. Last one that I'll do with you. We are going to solve for t. So I have my equal sign. There's my railroad tracks. Okay. My goal is to get t alone. So I need to move everything away from t, starting with what's furthest away. So I have a plus 5z. I'm going to subtract 5z because that's the inverse of adding. I'm going to do that to both sides. Cancels out on my left, and I'm left with 3st equals, I cannot squish the 38 and the 5z together, which is nice because then I don't have to do any math. But I just keep tacking on, but I tack on the minus 5z. From here, I'm trying to get t, right? I see that t is being multiplied by 3s. So I'm going to do the inverse, and I'm going to divide by 3s. And that's going to cancel out. I'm left with t alone equals 38 minus 5z. The s is another variable. I can't squish any of this together. So I just leave it there, and I'm done. Okay. Try the last ones on your own. Let's solve for x. Solve for a. Email me if you have any questions on the homework. Thank you.